The aim of this project was to design a 3D portal frame on Revit 2019 software based off the preliminary design sketch provided by our client. All sizings and materials chosen for the model were specifically selected as to best fit the client brief and comply with Australian standards. The model used span deck vertical wall cladding and clip lock classic 700 roofing as outlined by the client in the design brief. A 400mm thick concrete slab with edge thickening was also included in the model, as well as a 6-degree roof pitch. Other design parameters incorporated into the portal frame included a rafter load of 14 kilonewtons per metre, a building length of 28 metres, a frame span of 14 metres, and an eaves height of 10 metres, as written in the design brief. Other notes specified that cleats were to be added and windows and doors added to suit.
Hi, my name is Kyle and I'll be presenting the portal frame and mezzanine sizing information. Based off the 14 kilonewton per metre rafter load, 10 metre eave height and 14 metre frame span specified to us in the project brief, we've selected the portal frame sizing accordingly based off the design table provided. This rafter size required is a 356 by 127 UB at 33 kilograms per metre, and the restrained column required is a 406 by 178 UB at 54 kilograms per metre. As for the mezzanine, we modelled in an 11.1 metre by 6.6 metre mezzanine, exceeding the minimum requirements as per the brief, and normally showed a 254 by 102 UB column and beams at 22 kilograms per metre, supporting this. The design intent was to assume joists spaced out to support the floor.
Hi, my name is Josh, and I'll be discussing the design of the purlins and girts for our particular portal frame. As seen on your screen, we opted to use CIVL201 purlins to support the roof of the structure, and for the girts we have chosen to use C20019 in accordance to the BlueScope Steel manual guidelines. By remaining within the given guidelines from the manual, the portal frame structure will have a sufficient design. The selection process for the purlins was focused around the spacing of each frame plus the given parameters of a 1 kilonewton per metre wind load on the structure. From this information gathered, we have placed the frames 5,450 millimeters away from one another to give an inward and outward force of 2.27 and 1.24 respectively. By placing the frame at this exact distance, no bridging is required for the structure and the portal frame can easily withstand the wind load that is applied.
To cover the portal frame structure using appropriate and allocated materials, the Lysart Clip Lock Classic 700 of thickness 0.42mm was used for the roofing, complying with the overall depth of 40mm. The wall cladding utilised was the Lysart span deck as per the project brief specifications. This is 24mm in depth and 0.42mm thick as depicted in the table provided by BlueScope Steel. Ensuring the roofing is sufficiently fixed and supported, the Z-section purlins to which it is joined are attached to the rafters using 75 by 145 by 8mm gusset plates. These were chosen as they allow holes large enough to use adequately sized bolts to secure the purlin to the portal frame structure. My name's Kobe, and on behalf of the team, I'd like to thank you very much for your time.